Hello everyone, welcome to Athelete Learning Tutorial. So in today's tutorial, that is the day 3, we are gonna again practice use case demo with the calorie sample this time. Calorie sample, it is again a CSV file. Let me show you this file. This file looks like this somehow. We have this kind of data present in this file, okay, with some 10 to 50, some 10 columns, calories count, and effective date, okay, with all the other foreign keys which are present to join this, right? The customer ID. Now, as a first step, what do we always do? We import the PySpark package from Apache Spark to utilize the Spark engine and run your code in the Spark cluster with GCP Notebook, as we are using GCP Notebook. So in order to run your clusters on the Spark engine, which is a multi-processing engine, wherein the parallel processing is in place, and on the distributed data sets, with the resilient distributed data sets, the cluster allocates its nodes to the master and the server nodes, or you can say the task and the executors, the worker nodes, and which further distributes the task and the executors based on the requirements and the volumes of your data, right? So now, starting with importing the packages, first step is to import PySpark package, which is pip install PySpark from PySpark.sql import star, that is import all the functions which are SQL functions. Now from PySpark.sql functions import lit. I am specifically using this lit because this is majorly used whenever we want to convert any of the columns data types. So in order to cast the data types, we would need this further in our Python coding over here if we don't convert the data frames to Spark. So that is one of the basic difference. You can literally convert it directly, or you can convert it using substring once you convert your data frame to Spark. Okay, so today we will see how to convert directly in Python. Okay, now after this step, second step is to import your necessary machine learning library. So what machine learning libraries I'm going to install? I'm going to install NumPy as NP, Pandas as PD, Matplotlib.pyplot as PLT, import Seaborn as SNS, SkyP as SPY, and Altair as all. So last three libraries you see, SNS, SPY, and SLT, these are all data visualization libraries and statistics libraries. And import Matplotlib.pyplot again is a statistics and mathematical library, and used for data visualization basically. Now talking about NumPy is a mathematical library, and Pandas is your used for data manipulation, data reading, and powerful library for analysis, particularly data frames. So this is imported with alias PD. So numerical operations using NumPy. For working arrays, it's important with alias NP. Matplotlib creating static, interactive, animated visualizations. Seaborn is for statistics data visualization based on Matplotlib, and it is imported with the alias SNS. And SkyP is again a scientific and technical computing. We have imported this library with the alias SPY. And declarative, Altair for declarative. I want the declarative statistical visualization ability for Python, so I've imported alias as ALT. Alright, now in order to issue the Spark session, what we have to do is we have to create a Spark variable. From where? From the Spark PySpark library again. So from PySpark.sql, which we installed above, import Spark session, then create a Spark session variable which is going to store the session configurations, which is Spark session .builder.app name. I'm giving the app name as Athelete calories count this time. Use case demo by Ankita.config, spark.ty, port 4050.get or create. Okay, so this is my use case for the day. I'm going to use calorie sample file which I showed you here. Next, I'm creating a first raw data frame, okay, in my bronze layer. Again, we are going to apply the Medallion architecture, and we are going to leverage that using raw as bronze, silver for transformations and modifications and manipulations and cleansing, and then further use the gold layer for your visualization purposes and saving it as a final tables. So calories raw data frame as pd.read CSV with CSV file, this CSV file, calories raw df.head. Okay, so this is my raw data frame, and we are reading that. So we are able to read the file which is present in the CSV format. Again, I am using a session storage. You can use your permanent storages as per your requirements. I just needed it for this demo purpose, so I'm using it here. You can use your permanent storages. Okay, right. Next, so once we have our raw data available, like in a data lake, right? So this is just a sample, but you can assume your data lakes because the volumes of the data you might be receiving from a variety of sources or internet of sources might be more. In order to handle that big data, you should have sufficient storage spaces as well. Okay, next is print calories df. So I want to see the data inside this, right? Get or create. So you can either use head with the header, and you can also use the print statement to see the results like this. Now calories bronze. Now I want to create a Spark data frame, right? So we have just created one data frame which is not a Spark data frame. It was a pandas data frame, or basically you can say a generic data frame, which was helping you to read your data, right? Now we want to convert it to a Spark data frame. So in order to do that, I want to save it as a bronze data frame. Okay, so I'm writing calories. I'm creating a new data frame, calories underscore bronze underscore df equals to spark.create data frame. So I'm creating a Spark data frame here. From where? From my raw data frame which we created above, calories raw df. Okay, so once you do that, you can print your results to check using the show command, calories bronze df dot show. Now next is calories bronze df dot print schema. So I want to see, okay, what all columns are there in my data frame. So I can use print schema, and you can only use this command once you converted your data frame to Spark. So if you will try to use print schema with the pandas data frame or the raw data frame which you have created, it will throw an error. It will give you an error, right? Because this is specific to Spark. Okay, the code only works once you have a Spark data frame. Now next is, so we are ready with our bronze data frame, right? We are not making any changes in the bronze data frame. We are just trying to save the data into the data lake or in the raw format in the bronze layer. Now I want to apply certain transformations. I want to extract certain columns, and I want to typecast certain values inside my columns in my data frame. So in the silver layer, first of all, I'm creating a raw silver data frame again. So calories raw silver data frame. I'm not creating a final silver data frame right now. I'm creating a raw silver data frame because I want to apply all the transformation, and I want to see if my junior data engineer only has access to bronze, right? He's just extracting the data. Then my mid-level employee has only access to the silver data frames, which they get from the junior developers. And now they want to apply certain transformation and save it somewhere, so that your data is intact and it is saved from your bronze to silver layer. Whenever you apply certain changes, you save it at some other place, and then you can further share it with the business users or your top level stakeholders in your gold layer. Okay, so silver, talking about this calories raw silver data frame, calories raw data frame dot copy. I'm just creating a copy from my raw data frame or your pandas data frame, right? Because we haven't made any changes yet in the bronze as well. So if you print this, you can see the bronze and the silver. Okay, here I want to print the silver one. Okay, and if I run this, raw silver, I'm sorry, this is raw silver. So raw silver will be same like the bronze. Okay, now if you will create this from the bronze one, right, you will not be able to perform certain operations, like I'm saying typecasting, which I want to do directly without using SQL. I can do it using Python, but in that case the data frame has to be a generic data frame. It should not be a Spark data frame, right? So now print raw calories silver. That is why I'm using this approach in this case. Okay, now calories raw data frame, that is calories count. I want to convert this column. Okay, calories raw silver data frame calories count dot str. Since my data frame is a string, that's why I printed it, in order to check the schema. And now extract, since it was I want to extract the numeric value. If you see the data, it is something like 158 cal, right? If you have earlier checked this, the value is something like this, calories count 347 hyphen cal, and we just want this numeric value like 347 and 831, something like that, right? We don't need the hyphen and the cal. So in that case, what we have to do is we have to typecast it and convert it and extract the integer value. So I'm extracting the integer value here, that is from my raw silver layer. I'm not touching the bronze layer here. I'm just performing the transformation in the silver again into a raw silver data frame. Okay, so raw silver data frame, which column you want? I want calories count column. And what do I want to extract? I want str.extract /d. You know, /d stands for integer value, as type int, and we have given the type also as int. So if you will see here, calories bronze df.describe. Okay, this was bronze one. You can use this. It should be, I should let it go upstairs. This should be above this. Yeah, okay. Print raw calories silver. So once you print that after copying the data, and then okay, removing the cals. Yeah, so here we perform this operation, right? After applying data transformation to save the data in silver data frame to extract the numeric value from calories count column and removing as cal. So this is my data, how it does look like. This is how it looks like. And now from PySpark.SQL functions importlet, why I'm doing this? I want what? I want to add one more column. So I've extracted this. If you print this after doing this, okay, after doing this head, you see I only get to see calories count. I do not see the cal word attached to it. So we have extracted that data. Now we don't want to lose anything, right? We want that column also, but as a segregated column, as unit column. So what I'm doing, I'm trying to create, first of all, I want to convert my data frame, my normal generic data frame, pandas data frame, to my Spark data frame. So in order to do that, I'll create a new data frame, calories silver df is equal to spark.create data frame calories raw silver data frame. Okay, from where you are creating this? From your recently transformed raw silver data frame. Calories silver data frame show. Now once it is showing the same data as of now, no changes. Now we will perform the transformation. Once this is the Spark data frame, we will perform using SQL operations. We'll change it to we'll add a new column for the unit and then concatenate we'll add one more column for concatenation. So from PySpark.SQL functions import lit, calories silver df should have the unit also. So calories silver df with column, that is for adding a column, calories count unit. Okay, in the unit what will it store? The unit for this value lit as cal. Okay, it will only store the unit for each row. So calories, if you'll print it, calories silver df, I want to see whether this new column is added to my schema or not. So you see the last column is calories count unit. Now here it is, right? Now I want to see the data as well, you know, whether the value which we have provided it over here, which is added or not. Then what I am doing is I am adding calories df silver dot show. So here it shows me cal. Okay, so this is a segregated column and this is another column. Now we can concatenate this also. So I'm doing what? I'm trying to save it first. First I want to save this as a table. So calories silver df dot write mode append. Since this is the first time I'm updating and creating a table, save as table. Calories count silver table. We don't need to use the mode as such. It is optional, but it's a best practice to write. Insert append or overwrite mode. Okay, so once you have created this as a save this as a table, you can run to see the values from the table. You can run this command spark.sql select star from calories count silver table dot show. Okay, you can give any number of rows you want to see. I'm just given first 5 records, that's fine. Then we have effective date and you can see calories count here and calories unit there. You see it is not sorting the data, it is now giving me 203. Earlier it used to give me 347, right? Somewhere 347. So if you want the sorted data, you should write the query properly. Okay, I just wanted to check whether the data is there or not. Now calories silver df spark.sql select star. I want to concatenate both these columns. I want it to save it as a separate column here in this table. Calories count and calories count unit as a separate column, combined as a separate column. Apart from this, I want to utilize these for my visualization purposes, but then I want to store it as a common value as well, concatenated value as well. So what I'm doing here is, now I'm applying the operation on the Spark data frame instead of the generic data frame. So calories silver df spark.sql select star, I want all the columns, and then concat. I'm using a concatenation operation. The first column, that is calorie count, and the second column calories count unit as total calories count from this which table? I'm selecting my calories count silver table. Okay, so I'm saving all this I'm saving it in a data frame which is calories silver df. So now if you will see calories silver df dot show, you will run this command, you will be able to see 2 additional columns which we have applied using the data transformation. So you see there is one column which is calorie count without any units, another new column which only has the unit saved, unit stored, and the third column total calories count which has the unit as well as the calories without the hyphen. You see how it works. So we have transformed the data for adding three new columns and then transforming the data. Now calories silver df dot write mode, I want to save it as a table again, so I'm saving it in a new table, calories silver table, write mode. And now from this table I'm going to create my gold view. So calories raw gold data frame spark.sql select star from calories silver table. I want to see the data in this table and I'm storing this in my gold layer as calories raw gold data frame. I'm creating a raw gold data frame to show if I show you, it is the same data which is present in your silver table. Okay, nothing changed, the last new column being added. Right, now next we want to plot this graph. So from this raw, I think the data looks good for visualization purposes. We can utilize this. So I'm just creating final gold view from the raw gold view. So calories gold data frame, calories raw gold data frame. Now I'm using Altair library. So again used for data visualization purposes, for statistics data visualization purposes. So import Altair as alt, import pandas as pd. Okay, now first, since this was my Spark data frame, since we created this from Spark table, right, we created this from which table? Silver table, which was again created from the Spark data frame. So again this was a Spark table. Now we have to convert it to pandas first in order to plot the graphs or perform the data visualization operation. So how can we do that? So this is a new data frame I'm going to create as pandas data frame, calories gold data frame pandas underscore pd calories gold df. Okay, I want to convert this Spark data frame which is calories gold data frame to pandas as pd, so that I can see which data frame to be utilized further. So I'm giving it a suffix as pd. Now calories gold df pd, what do I want? I want to use 2 columns. I want to use effective date and I want to use with the effective date show me the results for all the calories count, how much calories burnt each day or each date respectively, right? So here I'm using calories gold df effective date. Now again we have to convert it to a date time function whenever you want to utilize this. Okay, so how can you do that? pd dot to underscore data frame calories gold df effective date, and format you have to give it as %d m and y %d, d for date, m for month, and y for year. Okay, and once you see the details over here, once you've converted the date, now we can plot the graph using Altair. So I'm storing everything inside the chart, okay, as a chart variable, which will store my entire configuration for my graph or my visualization. ALT, that is Altair library dot chart. Which data frame you are using? The pandas data frame, which we have newly created here after converting into pandas. Dot mark bar and encode. On the x-axis I want to plot effective date, and on the y-axis I want to plot calories count. Okay, now once you have stored the values after converting it to pandas, okay, then I'm just trying to print this chart. So display the chart, you just write the print command or the simple name of your variable chart, and it is showing me, okay, on January 5 it was somewhere here, calories count January 12, January 26, and maximum on somewhere 27, 28 January, somewhere around this 1000 values. Okay, so this is how you can create your end-to-end data frame from bronze to silver to gold layers, and see the data cleansing, data transformation, data manipulation, data analysis, data quality, data governance, everything being managed in one single platform easily using Spark. So that is the beauty of Spark. I hope you like this video and it makes sense to you and it help you a lot in your journey to learn Spark and PySpark and SQL and Python together. So in any which ways, if it has helped you, do like, comment and share this videos and spread the word, and subscribe for giving me more motivation to this. Hope you all have a nice day. See you later. Bye bye.